Hello students, welcome to Educate. In the last class we have discussed till aldehyde and the chapter and ketone of third chapter of organic chemistry, that is chemistry 2. Now let's see about the carboxylic acid. Carboxylic acid, you already know what is that. In that one carboxylic acid, to the acylic carbon, one side there will be alkyl group and another side OH group, then it will be called carboxylic acid. Carboxylic acid is one of the earliest known compound, and that's why there is a number of compounds of the carboxylic acid which has been named in common method also. So let's see some of the that was about the nomenclature directly. So watch out here carefully. First one is here that when there will be only one carbon atom here, that means here C double bond O, one side is hydrogen and another side is OH. That means this carboxylic acid is of one carbon. So it is common name is formic acid, and it is of one carbon, that's why methanoic acid. When you will have to write the IPAC name, then you will have to consider about the number of carbon atom. And common name is based on the sources from which the carboxylic acid was obtained. As for example, the formic acid was obtained from the red ant, which in Latin name called formica. That's why that is called formic acid. That means HCOOH is called formic acid. In the same way, CH3COOH, that is here in CH3COOH here, the IPAC name will be based on the number of carbon atom. Here is 2 carbon, so that's why it's called ethanoic acid. And in the IPAC name, it is called acetic acid because it was obtained by vinegar. So that's why that is called acetic acid. Same here, if 3 carbon atom, then propanoic acid, and here common name is propionic acid. Okay, here nic acid here, so that is difference here, propionic acid, this one, and here okay, propanoic acid, and here propionic acid. And in the same way here butanoic acid is the IPAC name because number of carbon atom is 4. And guys, here I think no need to tell that the carbon of the functional group will be also counted in the main chain. As in case of aldehyde and ketone, the carbon of the functional group was also counted in the main chain. In the same way, when we will have to write the IPAC name of the carboxylic acids, then we will have to also count the carbon of the functional group. Now here same, so here 4 carbon, so that's why butanoic acid, and here common name is simple here, butyric acid. Okay, when you will have to prepare for the NEET examination, then common name is quite important, and not only for NEET, for the CUET obviously, because when you will find out the nature of questions of the NEET examination and that of the CUET examination, then that is similar. But it's also fact that in case of the CUET examination, the level of questions is something easier compared to that of the NEET examination. Now anyway, let's see butyric acid here butanoic acid. Here methyl group here goes on the structure. This structure will be here. This methyl group is bonded to here, this carbon. So 2 methyl group is bonded to this carbon here, and then after each here, and then after each COOH. So main chain may be this one or this one. So main chain is of 3 carbon. So that will be propanoic acid. And methyl group, this is substituent. Yeah, basically this one will get first position, second position, third position. The carbon of the functional group will acquire first position. So methyl group is at the second position. So that's why it will be called 2-methyl propanoic acid. So IPAC name will be 2-methyl propanoic acid. And when you will have to write the common name, so it is isopropyl. Here CH3CH CH3. So through secondary carbon atom, it is bonded. So it will be called isobutyl. Oh, sorry, isopropyl. So it will be called isopropyl. And here carboxylic acid it is. So that's why it is called. It will be in common name. Its name will be isobutyric acid. Butyric acid means normally the COOH group will be bonded. Here total number of carbon atom is 4. So butyric acid and isobutyric acid, because here isobutyric acid, because here 3 butyl group here. This one is isobutyric acid. That's why. Okay. Now for how to write IPAC name this compound. Here it will be, when you will have to write, okay, a common name is oxalic acid, that you will have to keep in the mind. That means 2 COOH group bonded together through single covalent bond will be called oxalic acid. So common name of the compound in which the 2 COOH group are bonded with each other through single covalent bond, that will be oxalic acid. And how to write the IPAC name? So when you will have to write the IPAC name, so let's see, this is one carbon and this is second carbon, or this is first carbon and this is second carbon, whatever you would like to consider. So there, this compound is made up of 2 carbon here. So that's why it will be called ethane, and 2 carboxylic acid it is. So that's why that will be called ethane dioic acid. Okay. Now in the same way here, this COH and this is COOH. So 1, 2, 3, or 1, 2, 3, whatever you would like. So propane, keep in the mind, E will be retained because di word will be inserted. Here di word has been, di, this word has been inserted between the here alkyl part and the oic acid. So that's why E will be retained here. So that's the reason here, when there will be 2 COH group, when there will be 2 COOH group in the compound, then E of the alkane will retained, and here when there was only 1 COH group, then the E was replaced by the oic acid. So here total number of carbon atom here is 3. So that's why propane dioic acid. Same here, let's see, here is 2 carbon atom. Watch out here. Here CH2 whole twice. That means don't be confused. When there will be CH3 whole twice. So CH3 can have, that means CH3 will be considered as 2 substituent. So that means 2 methyl group is bonded together to a carbon atom. And here CH2 whole twice, that means it will be continuity. Because when you will watch out, if you will write 1 CH2 here and then after here, so its octet will be not complete. So CH2 whole twice means it will be in the continuity. If CH2 in whole 5, that means these 5 will be in continuity. CH3 whole thrice means to a carbon atom 3 methyl group is bonded. But if there will be CH2 whole thrice, that means the CH2 that will be in the continuity to maintain their octet. So here CH2 whole twice, that means here is 2 CH2 bonded together. They are in continuity. Maybe some few students will not feel comfortable if I solve this question directly, and students who have studied the chapter of the organic chemistry somehow, then they will name this compound very easily, and he will not felt the necessity to expand the structure of the compound. But maybe few students may feel difficulty, so that's why I am doing here. CH2 whole twice means here 2 CH2 is here, and to the one side there is 1 COH group, and to other side there is another COH group. So total number of carbon here is 4. So that will be called butane, B-U-T-A-N-E. E will retain because number of COH is more than 1. So that's why butane E will retain and 1,2-dioic acid. Oh, sorry, 1,3-dioic acid. So this name is butane dioic acid or butane 1,3-dioic acid. Okay. Same here. Pentane dioic acid because here there will be 3 CH2. That's why pentane dioic acid. And watch out here. This one is this common name is quite important, especially for those who is preparing for the competitive examination. Okay, for the 12th board examination, it is also important. But for the NEET competitive examination like CUET, NEET and main examination, this common name is quite important. So keep in the mind only simple that when two COH group bonded together, that will be oxalic acid. If between the two COH group there will be one methyl, then that will be called malonic acid. If there will be here two CH2 group bonded between here, there will be two CH2 group between the two COH, then that will be called succinic acid. Okay, succinic acid, that is more important for the NEET examination. Succinic acid. Now CH3 whole thrice it is here, so that is glutaric acid. Keep in the mind. And here, if you would like, then make this one name in a separate pages and revise them in during a certain time interval, like within the time gap of 24 hours in first instant, then after in 5 days, then 7 days, then 10 days, then 1 month, and like that. So that will remain in your mind. So that is here, if there will be 3. So succinic acid and glutaric acid, that is too much important for the students who is preparing for the NEET examination. Too much important. It is very important. Yes, adipic acid is also important, but these two is quite important. If there will be 4 CH2 group between the two COOH group, then the common name will be adipic acid. And IPAC name here, very easy. Here 4 carbon and here 1 5 and 1 6, total 6 carbon. So hexane E will retain and dioic acid. Okay, same here in this compound. Okay, let's see. About the last one. Here, that is this compound. So here CH2 and COH. There is CH2 and one COH is bonded to this compound. Either this in this form you may write or directly that. And then after here, this one has this CH2 is bonded to this CH. So here CH, here COOH. Then after it is bonded to this CH2. So here CH2 and it is also bonded to COOH. Now, if we will count here 1, 2, 3, 4, 5. So this COH you cannot count in the main chain. These 3 functional groups in this molecule, there is 3 groups of the same functional group. So their seniority is same. So seniority is same. So it will be not fair that you include the 2 group in the main chain and don't include the 3rd one in the main chain. So either you include all of them and or don't include any one of them. So you cannot include all the groups in the main chain. That's why don't include any COH group in the main chain. So let's see here. So how to do? Oh, once again I have to draw the structure. So here CH2, COOH, so don't include this one and this one. include in the main chain. So now do the numbering. If you do the numbering from right to left, so 1, 2, 3. So first position COH group, second position COH group, and third position COH group. And if you will do numbering from left to right, so at first position there will be COH group, second position COOH group, and on the third position there is COOH group. So we can write here E will retain because number of COH group is more than 1. So we will have to write the prefix tri. So tri. So that's why the E of the alkane will retain. So it is propane. So of propane we will retain the E. So PROPANE is propane, and at first, second, and third position there is carboxylic acid. So that's why we will write 1, 2, 3 tri carboxylic acid. Recall that we have discussed also in the case of aldehyde. If there was compound like this here, CH2, CHO. So how we have done the nomenclature? We have not included this chain, this one, and this one in the main chain. So that's why 1, 2, 3 we have written, and so we have written the E of the alkane. So it was propane. So here that will be PROPANE. E was written, and then after 1, 2, 3 tricarbaldehyde. Okay guys, that was the nomenclature. Let's proceed. Now let's see here in the benzene. So when COH group bonded to the benzene, so common name is benzoic acid and IPAC name is benzene carboxylic acid. Initially, nowadays the name benzoic acid has been adopted by the IPAC system, but earlier its IPAC name was benzene carboxylic acid because COOH group was not included in the main chain. So that's why the suffix carboxylic acid was used on the place of oic acid. Instead of using oic acid, here carboxylic acid was using because the functional group COOH was not included in the main chain. So here it is, that's why common name benzoic acid, benzene carboxylic acid, or benzoic acid. Now let's see how to write the IPAC name system. This compound, guys, a number of times I have told that when the open chain will contain the functional group, then the name of the compound will be based on the open chain and the cyclic group, either aliphatic or the aromatic. The cyclic group will consider as the substituent. When benzene will be their substituent, then we will tell phenyl. If there will be the suppose cyclohexane be the substituent, then we will write cyclohexyl. If cyclopropane, then we will use the name of the suffix as cyclopropyl. So let's see here. It is so open chain here. It is of 2 carbon, and there is a functional group in the open chain. So this group, that is benzene, will be considered as substituent, and the name of the substituent here will be phenyl. Firstly, we will have to do the numbering here. So this one will be first carbon and this will be second carbon, and this phenyl is not including in the main chain. That's why here we will write 2-phenyl. At second position the substituent is phenyl. So that's why 2-phenyl, and here it is of 2 carbon. So that's why ethanoic acid. So that's why the name is 2-phenyl ethanoic acid. So for the IPAC name system, we have considered about the number according to the number of carbon atom. During IPAC system of nomenclature, we consider the number of carbon atom in the main chain, and here in the common name by the source through which it was obtained. But here it is commonly it is called phenyl acetic acid. Like here, if CH3COOH is there, so that was called acetic acid. So to the acetic acid, that means of the 2 carbon chain, the phenyl group has been attached. That's why it is called phenyl acetic acid. Guys, keep in the mind here phthalic acid, and here the common name of this compound. You keep in the mind. This is important for those students who is in the 12th board examination also. In addition to those who are preparing for the competitive examination. So this one is quite important for the all of the format like 12th board examination, for the IIT main, for IIT advanced NEET examination, as well as for the CAU ET examination. That is, in the benzene, if the 2 COOH group will be bonded, then that will be called phthalic acid. So its common name is phthalic acid, and IUPAC name very simple. Here 2 carboxylic acid is bonded to 1 benzene, so that's why benzene 1,2-dicarboxylic acid. Very simple here. It is 1,2 or here 1,2, whatever you would like to do the numbering, but common name will be same. Let's see about writing the IUPAC name of this compound. About that I am discussing. Let's see about first question. pH means phenyl. So that means here in this compound, about this compound, here it is phenyl here, that means benzene. This one is the structure of this compound. So very simple, you will have main chain will be 1, 2, 3. Here one first position, because we will have to give first position to the functional group, and the carbon of the functional group carboxylic acid also includes in the main chain, and here only one carbon here of the functional group. That's why that will must be included in the main chain. Same procedure in case of aldehyde also. I hope you have watched that videos carefully, in which I was discussing about the IPAC system of nomenclature of aldehyde and ketone. So let's see here. So this one, this phenyl group, this is benzene, that will be considered as substituent, and its name will be phenyl. So it will be 3-phenyl, and this substituent is at for third position. That's why 3-phenyl. And here 3 carbon atom, so that's why ethanoic acid. Here E has been replaced. E has been replaced by oic acid. Only one COH group here, only one COH group, so that's why E has been replaced. Now second question. Let's see second question about that. This one. Here CH3 whole twice, that means 2-methyl group is bonded to this carbon atom. So take this carbon here, the 2-methyl group bonded. So this one, and here's this one. So 2-methyl group. Then after here it is doing double bond formation, CH-COH. Guys, if it will be written in this form also, suppose instead of writing in this one, this side here CH3, then you will have to write 1, 2, 3, 4. Usually a number of students know how to write the IPAC name of this compound, even though they do mistake in the examination, and a number of students do the mistake in the competitive examination. What should they do the mistakes? They include the main chain till here only. but length of the chain is from here to here. Be careful. Here chain has not been terminated. Termination of the chain is from here to here or from here to here. So this chain is of three, not only of 3 carbon. This chain is of 4 carbon. So this chain is of 4 carbon, not the 3 carbon atom. And guys, a number of students do the mistakes. That's why you take this one very carefully. That if there will be bending of the chain, that means carbon chain has been tilted any side. That not means that has not been included in the main chain. As for example, take our thread, bend them. So when you will have to consider the length of this string, then you will have to suppose this string. Just a moment. Suppose you will have to find out. Suppose you will have to find out the length of this earphone. Like this, it has been kept. So length of the carbon chain is not from here to here. Length of the carbon chain is not only from here to here. Length of this chain, length of this earphone is from this end to either this end you take or to this end you take. That means length of this earphone is from here to here or from here to here. Depending on the longest length here is depending on this branch is lengthier or this branch is lengthier. Which will be lengthier? So length of the chain, longest chain will be from here. Suppose this one is lengthier. So from here to this chain, the longest chain will be that. If it is in tilted form also. So length of this string will be from this end to this end. Okay guys? So here don't do silly mistake in the examination. Always keep in the mind the length of the chain will be from one end to other end. And one, because the carbon atom which is bonded to the main chain, that will have to include in the main chain. Okay, so let's see here. Oh, again I am drawing the structure. So it is carbon here, it is doing double bond formation, CH, COH here, and then after CH3 and suppose CH3. So that will be 1, 2, 3, 4. Or straight wise also 1, 2, 3, 4. So you go this side straight wise or come downward, doesn't matter. Length of the chain will be same and same here, methyl and methyl here. So this methyl will be considered as substituent. So at third position there is a substituent methyl and main chain is of 4 carbon. So main chain is of 4 carbon, so it will be butane. And at second position there is double bond. So we will write here for this one. So at third position there is methyl, so we will write methyl. Then after is but here, and second position there is double bond, so but 2 in En only, and COH is at first position, so simply write oic acid. So its IPAC name of this compound is 3-methyl but-2-enoic acid. Okay, now let's see how to write the IPAC. This was here how to write the IPAC name of this compound. Now let's see how to write the IPAC name of this compound. So let's see. COH group here, COH group here, and here methyl group. So to the main and the ring here 1, 2, 3, 4, 5. So number of carbon in the ring is 5, and in this ring, so that is it is cyclopentane. Cyclo means 5 carbon, so it will be called cyclopentane. This is functional group, so that's why the carbon atom to which carbon atom of the cyclic group of the cycle, carbon atom of the cycle to which the functional group is bonded, that will get acquire first position. So it is second position. So at second position it is methyl, and it is so methyl here second position, and it is cyclopentane, and here carboxylic acid. Because the COOH group you cannot include it in the main chain, so that's why you will have to use the suffix carboxylic acid, and during that course you will have to retain the E of alkane. Alkane is here cyclopentane. You will have to retain the E, and then have to write carboxylic acid. And at second position there is methyl, so write 2-methyl. So IPAC name of this compound is 2-methyl cyclopentane carboxylic acid. Okay guys, very easy it was. This question was also very easy. Now let's see about this question. Mention here, this one is benzene. Okay, benzene, and the functional group attached is carboxylic acid, nitro group, and nitro group. For the nitro group we use the prefix, and here that is also the NO2, the functional group NO2 are junior than COOH group. So the carbon atom of the benzene to which the COOH group is bonded, that will get first position. Then after go clockwise or anti-clockwise and consider that about the next functional group. So it is first here, so second carbon this one, third, fourth, fifth, sixth. So the functional group substituent that is present at second carbon, third carbon, and sixth carbon. So it is okay. You may also consider this one. So functional 1, 2, 4, and 6. That is 13. And when you do the numbering in clockwise, so 1, 2, 3, 4, 5, 6. So that will be here. Numbering will be summation will be 1 plus 2 plus 4 plus 6. That is 13. So either you do the numbering from clockwise or in anti-clockwise, same summation you are getting. That means here, and all of them have the same seniority. So that means either you do the numbering in clockwise manner or in anti-clockwise manner, the IPAC name will be same. So its IPAC name will be, that was the summation. So its IPAC name will be at second position, fourth position, and sixth position. There is nitro group. In the compound there is 3 nitro group which are present at second position, fourth position, and at sixth position. So we will write here 2, 4, 6 trinitro, and then after is benzene, carboxylic acid, and since carboxylic acid has been also, the name carboxylic acid has also benzoic acid, the word benzoic acid has also been adopted by the IPAC system. That's why we can also write okay guys, easy. Okay, now let's see its preparation. Method of preparation of carboxylic acid. These reactions we have discussed a number of times. That's why I shall not tell you in detail. Simply I am telling here, as as we have studied that when the alkane will get oxidized, there will be formation of alcohol. When alcohol will get oxidized, there will be formation of either the aldehyde or the ketone, and when there will be uh, here aldehyde or ketone will get oxidized, there will be formation of carboxylic acid. And also, if you oxidize the carboxylic acid, there will be formation of CO2, carbon dioxide. So here it's alcohol. So the alcohol, when treated with alkaline KMnO4, alkaline KMnO4 is a very strong oxidizing agent. So, and second times you prepare this one. So there will be formation of carboxylic acid. What actually here, like R CH2OH, when we react with alkaline KMnO4, so it will provide, it is an oxidizing agent, so it will provide nascent oxygen. So this CH2OH will get oxidized into COOH. So firstly, here potassium also. So firstly, there will be formation of RCOOK. Potassium, yeah, alkanoate will form. And then after, when you treat the acidic water, then after this potassium will get replaced by hydrogen. And there will be formation of RCOH and potassium will get separate here. Like QH or K plus there will be. So actually here the same reaction is nothing different. Same reactions about which we have discussed a number of times, that alcohol is treating with alkaline KMnO4 and second time with water. So that is formation of carboxylic acid. Same compound here. Keep in the mind, especially who is preparing for IIT main and the NEET examination. In the 12th board examination, question was not frequently asked in the previous years, but it not means that in the next upcoming examination it will not ask. It may ask in the future. You cannot say that in the upcoming examination this will not ask. It may ask. But who is preparing for the IIT main, the NEET examination, as well as for the CUET examination, always keep in the mind that the mixture of chromium trioxide and H2SO4, that is called Jones reagent. The mixture of chromium trioxide and H2SO4, that is called Jones reagent. Who is preparing for the NEET examination, always keep in your mind. Then after this here, from alkyl benzene, this one. Listen here. When alkyl benzene is here, whatever be the length of this carbon chain attached to the benzene, always benzoic acid will form. So firstly potassium benzoate, and then after water, acidic water has been treated, and benzoic acid. So keep in the mind, whatever be the length of alkyl group attached to the benzene, always benzoic acid will form, or the potassium salt of benzoate will form. Okay, keep in the mind. Let's see here, from nitriles and amides, these questions about this method of preparation you can do by yourself also. When you was preparing the aldehyde, then firstly you had included, you had reduced the nitrile firstly, and then after had passed the water, acidic water. And when you was preparing the ketone, you was reacting the nitrile with Grignard reagent, and then after was passed water. But if you pass the water directly in the nitrile, there will be a formation of firstly the amide, and then after that amide will further gives the carboxylic acid. How? Let's see. You can do by yourself also, even though I am so doing this reactions here. So take this compound. Suppose I have taken this compound. It is propane and nitrile. Keep in the mind, E has been retained. When you add water, acidic water or whatever be that, acid is acting as a catalyst only. So H3O plus, actually water is acting here. So whatever you want to take. So nitrogen is more electronegative compared to carbon. So hydrogen, among the H3O plus, hydrogen is the positive part and OH minus is the negative part. So OH will bond to this carbon and hydrogen to this nitrogen. So compound become then after again water when react or H3O plus, whatever you would want to write. Even though again nitrogen is the negative part and carbon here is positive part, because nitrogen is containing lone pair of electron and it is more electronegative than carbon also. So that's why nitrogen is the negative part and carbon is the positive part. So hydrogen will go to this nitrogen and OH to this carbon. So compound will become you are already familiar then that when there will be two OH group bonded to the same carbon atom, when there will be two OH group bonded to the same carbon atom, that compound will be unstable and that hydrogen of one OH will combine with other OH. So either this hydrogen combined to this OH or this hydrogen combined to this OH. So I am imagining this is reducing. So there will be formation of H2O. This oxygen will do double bond formation to the carbon. So structure will be it will be called amide. And what is IPAC name? 3 carbon atom. So that will be propane. Propane. And here amide, that is vowel. So E will replace by amide. So propanamide. E has been replaced by amide. It this one, and now again pass water. So what happened again? Hydrogen will go to this nitrogen. So that will release us. When hydrogen will get bonded to this NH2, that will become NH3. NH3 means ammonia, that will get separate out. And the OH will bond to this carbon. So compound become so there will be formation of a propanoic acid and the ammonia. That was okay. This one, how that has been formed? First from nitrile. So nitrile is a so much useful compound that you can form the aldehyde, the ketone and the carboxylic acid also. Very easy it is. Now let's see. Amide, how water passed, how formed, you have already seen. By taking Grignard reagent, by this compound, it is very easy here. Even though, let's see. Okay, directly I am telling you here. Because you are already aware about the activity of Grignard reagent in the various compounds. So same here. It is CO. Here shape of the CO2 molecule. The shape of CO2 molecule is linear. Keep in the mind. The shape of molecule CO2 is linear. Both the oxygen bonded to the carbon will lie opposite to each other, and there is no any lone pair of electron at the carbon atom. So there will be also no bending of the bond. So that's why the shape of CO2 molecule is linear. Let's see here. So our bond will dissociate from here. Magnesium will go to one oxygen here. Along with that, hydrogen will go, and this alkyl part, magnesium. Why? Because magnesium is the positive part, and when bond will dissociate between carbon of the alkyl and of the magnesium, then magnesium is the positive part as it is a metal and carbon will be the negative part. So alkyl will be group that will bond to this carbon atom and magnesium bonded here. So suppose this carbon atom here, so this oxygen is this is the oxygen to which the magnesium has not been bonded, and this is the oxygen, that means this oxygen, this is the oxygen to which the magnesium has been bonded. So magnesium has been bonded here. Now when water has been passed, and that means acidic water, so magnesium will combine with OH part of water. There will be H plus and OH minus sign. Magnesium is the positive part, so that will combine with OH part, so that will become MgX and OH, and this had H plus will bond to this O minus, so there will be formation of this compound, carboxylic acid. Now from acyl halide and anhydride. Listen here. This one, what's its IUPAC name? It will be propyl, P-R-O-P-O-Y-L, propyl chloride. When the halogen will be directly bonded to the acylic carbon, then don't consider halogen as a separate functional group. So compound name is acyl halide and the suffix used is oil halide. And instead of writing alkane, here we write alkyl. So it will be name is propyl chloride. This is when reacted with water. So water, so you already know here H plus and OH minus. So bond when dissociate from here, this is the positive part, carbon, compared to the chlorine, carbon is the positive part. So carbon is the positive part, so OH minus will bond to the carbon and chlorine the negative part. So this chlorine will bond to hydrogen. So there will be a formation of HCl and this OH bonded to this carbon. So it will be CH3, CH2, C double bond OH. That is here. Carboxylic acid will form and HCl, that has been shown by Cl minus. Same when you will take OH minus ion, alkaline water here, when you will take, then also there will be a formation of alkoxide ion, alkanoate ion and the chloride ion, and then after passed water. So there will be formation of carboxylic acid. Same here, let's see its structure. What's the structure of this compound? This compound. And how to write the IUPAC name of this compound. This compound is here. This whole is bonded to one oxygen. So one oxygen here. Here is C. So CO this one, and here C6H5. Like that also here C double bond O and C6H5. That means C6H5 C double bond O. Like this one, two groups is bonded to one oxygen. So to one oxygen, the two group has been bonded. Whole this structure that will be called acid anhydride, and it will be acid and hydride, and here benzoic and here benzoic. So that's why benzoic anhydride. So when you will pass water, then what will happen? Let's see. You already know water H plus and OH minus ion. H plus will go to this oxygen. So if bond will dissociate from here, so hydrogen will remain bonded to this compound. So this structure will be, for this one structure will be this benzoic acid, and the valency of this carbon, acylic carbon atom, become destabilized, and it is the positive part. So hydrogen cannot bond to this carbon. So to this carbon only OH minus can be bonded. So this OH minus ion will be bonded to this carbon. So a structure will be here. That means two molecules of benzoic acid has been formed. So that's why two molecules of benzoic acid will form. When the water will pass to the acetic anhydride, to the acid anhydride, when water will pass in the acid anhydride, there will be a formation of two molecules of carboxylic acid. And when the two molecules of carboxylic acid will combine together, there will be release of water. And that means when a dehydration of the carboxylic acid molecule will take place, then there will be formation of acid anhydride. Okay, that will come later on also. Keep in this your mind. That will be feel helpful for you in the chemical properties of the carboxylic acid. That was. Now same here, next compound. Consider about this compound. What is this structure? So here C double bond O, it is clear. C double bond O is, this one is also clear, and here is oxygen. Same type of compound here is. So it will get converted to ethanoic acid, and here it is benzoic acid. So that's why benzoic acid and ethanoic acid. Okay, very easy. Same. This one is benzoic acid, benzoic group, and this one here methanoic acid. Next, from ester. How the ester is formed? Ester was forming. Recall the chapter of alcohol, phenols, and ethers. When the alcohol was combining with carboxylic acid, there was formation of ester, and during that course, water was releasing. So when you will add water in the ester, there will be formation of carboxylic acid and alcohol. When carboxylic acid and alcohol was combining together, there was release of water, and finally the formation of ester was taking place. So when you will add the water in the ester, there will be formation of alcohol and the carboxylic acid. How that is taking place? Let's see. So here, let's see about this compound CO. That means here this oxygen is doubly bonded to this carbon, and O and C2H5. That means this oxygen is singly bonded to this part, and that will be obviously bonded to this acylic carbon atom. The structure is like that. This compound. Now pass acidic water. Actually water is taking here, water takes place in the reaction. Here H plus acid act as catalyst. So very simple, H plus and OH minus. So H plus will bond to this oxygen. So when H plus will get bonded to this oxygen, then bond will dissociate from here. Bond cannot dissociate from here. Why? Because this bond is more polar. So bond will dissociate from here. So this become C2H5OH, and the OH part will get bonded to this carbon. So there will be formation of benzoic acid and alcohol. Same, this reaction, this one here, same. On the place of benzene, it has been, propyl group has been taken. On the place of benzene, propyl group is here. So that is the reaction is taking place. NaOH, okay. I think here you might be feel difficulty. So let's see. I am solving this question. So what will happen here? It will dissociate into Na plus and OH minus. So what will happen here? The OH minus part, Na plus will get bonded to this oxygen. So bond will dissociate from here, and OH part will bond to this carbon. So compound become now when you have to replace this sodium, then pass acidic water. So doing that, when you will pass acidic water, the hydrogen will replace this sodium. So compound become that is. So guys, that was about the nomenclature and the method of preparation of carboxylic acid. In the next class, we will discuss about the questions related to this one, important questions related to that one, and in addition to that, we will discuss also about the physical and chemical properties of the carboxylic acid. Okay guys, so it's all for the today class. Thank you, Team Educate.